Hello everyone, my name is Navneesh Chandalya and today I had again came up with a new project which is a kidney stone prediction web application. So if we talk about kidney stone prediction, so what type of output we could think we can give? So we can a doctor will only say that the kidney has a stone or kidney don't have a stone by seeing the report, right? So this is a binary type of output. So uh, classification algorithm is classification algorithm used where only this type of data is present, like only this type of output is present. That is, we have to predict only yes or no type of data. So, first of all, importing the libraries. So first we will import the pre-processing library to pre-process and visualize the data. Then we had imported all the classification algorithm. You can see all type of classification algorithm we had imported here. Then after that we had imported different type of for different type of models for sorry for creating the models. We have all the libraries which are necessary, and then for finding how much good our model is, we had imported all that libraries, like for training and testing the model. We need model selection, like train and test, to split the data into train and test. Then to check whether our model is how much our model is efficient. So for that we need a confusion matrix and classification report and accuracy score. Okay, so we had done all this, and then for dumping and loading our data, we had imported the chocolate file. Okay, then I had also we are using, like I am using Google Colab. So I'm not doing that. I'm downloading the data from the Kaggle and then uploading it on this uh, Google Colab. What I am doing is I am directly downloading my data set from the Kaggle website. So for this we need a library which is named as Open Dataset. So I have to install this library here. So I installed it, and then uh, I had downloaded my dataset through this command, and you can see that I have my data. Okay, then loading our data, uh, giving it in the data frame variable. Data frame, we are storing it in data frame variable. Then processing our data, and this is the pre-processing and step. And in pre-processing, we check that what type of data we have. Is our data null, or is our data have duplicate items? Okay. So we can see that our data uh, is my data is of numerical type, that is an integer or float only. So I don't have to encode my data set, or I don't have to handle the string data. Okay, so much more complexity has been decreased. Then, if we see the null data set, so check about the null data set. So we could see that uh, we don't have any null data set. So it's also a good sign that we have decreased. This data set has decreased most of our complexity. Okay, then duplicated data sets. This is also not present in our in this data. Okay, then checking about the oversampling and undersampling conditions, so we can see that there is no undersampling or oversampling conditions, since there is not much difference between the 0 and 1 data. Then visualizing our data. So first of all, I had plotted the histogram, and basically his plot, what is does is plot univariate and bivariate histograms to show distribution of data sets. Okay, so here we can see the distribution, how our my data how our data is being distributed. Okay, to the histogram. Then I had plotted the pair plot, and pair plot plot pairwise relationship in our data set. Okay, so you can see that the pairwise data set is being plotted. Okay, like from id to id to gravity and all other columns. Okay, so uh, uh, this pair plot I had plotted, and you can say what you can see what type of pairing between two columns. Then I had checked about the correlation, that how my data is correlated. Okay, then plotting that correlation through heat map, and this you can see that the data of the one column, how it the one column is correlated with the other columns. All the columns I had taken, and for all the columns I had checked the other more columns which how it's being correlated. And as I don't want for correlation for all the columns, I want the correlation for target column to the other column. Okay, so I had plotted for that also. I had plotted for target column with the other column. All right, from the target column from with the other column. Then splitting the data set, I had split the data set into x train x test, y train y test. Okay, and I had taken the test size as 20% of my data set. Okay, then preparing my model, and for preparing my model I had first I had first declared a variable, list type of variable, where I had appended all my classification algorithm, then checking its result, and checking which type of algorithm has the least cross valid least errors and least and high mean value. Okay, so we can and sorting it in another in ascending manner, descending manner, and taking the results, we could see that random forest classifier has the least error values and uh, uh, maximum mean value and least error value. Okay, so taking this algorithm, uh, we will go further. Now, first we will load our test dataset. As you can see that here I have two type of datasets, that is test and train. So I will use now the test dataset and see how my data, how efficiently my data is working. Right. So for I had made different algorithms object, and fitted my, or I had passed my x and y value into it. Okay, so I had and predicted that how efficient my algorithm is. Okay, so if we can see that yeah, that is this extra tree classifier, and this gradient boosting classifier is giving me a good result, pretty good result. And this first uh, four algorithms I had taken here. Okay, then I had predicted for RFC, since my RFC score is best and error value in my RFC, that is random forest classifier, is low and mean value is high. So we had taken for the RFC, it is random forest classifier, and predicted the value, and we had seen that it's giving me a pretty much good value. Then to test how my data is working, so I had generated a classification report, printed it here, and we can see that it's giving me a good result. Then I had dumped my data. Okay. After that, this was our model, and now going for the UI phase, that is front end phase. And for front end phase, we had used Gradio library, and so we had imported Gradio library. Then we had imported joblib to load the data. Okay, then pandas and numpy, we had not used numpy here. Then first of all, I had made a function in which I had passed all the input variables which will pass here, and which is necessary to predict the output. Okay, then I had made a dictionary, and I had matched it with its key. Okay, then this we had returned the predicted value. We had predicted my result, and I had returned it here. Then I had created a UI through the Gradio, and then I had launched the app. So let's launch our application. So click on this link. So I will navigate to my this file where my this web app is running. Okay, so we will took some data of zeros and ones and predict and see that how our model is working. Since it's saying that it's 100% accurate, so we will check that is it 100% accurate or not. So let's take this data, and this is a fourth, and first of all gravity, then pH value, then osmolarity, and then its conductivity, and then its urea, and then its calcium. Let's see. And first time to give the output, it takes some time, but after that it will don't take much time to predict. So our output is 1, and here also our output is 1, so it's a good sign. Now let's predict about for the 0. And so first is this gravity, then pH, then it's osmolarity, and then conductivity, urea. So basically the test for the kidney stone is done but through your urine. So we had tested for the urine here, and you could see that our output is 0, and here also our output is 0. Thank you for watching this video.